Okay, good afternoon class. Welcome back to school. So I hope that you did have a good time during the spring break. I also hope that you didn't forget anything. But just in case, here is some review of some formula or knowledge that you've learned from the course right before the spring break. So here are some summary of formula for calculating the confidence intervals. So there are different scenarios. Under different scenarios, we have different formula. Okay. So usually the most difficult part, the crucial part in answering or solving some problem is to find out the appropriate and correct formula to be used. Once you can identify the correct formula, the rest will be just substitution of numbers and routine calculations. So we consider a single sample from the normal distribution. In case you have a single sample and drawn from a population that long to follow the normal distribution. Then, if you want to construct a confidence interval for the population mean, there are two different scenarios. Whether the population variance sigma is known or not. If sigma square is given, is known, then we will use this formula. Now this Z1 minus alpha 2 is the quanta of the standard normal distribution that can be obtained from that can be obtained from the standard normal distribution table or by using R. Now, in case when sigma square is unknown, we will estimate by using the sample variance or the sample standard deviation S. But the quantile usually is no longer obtained from the normal distribution. It is obtained from a so-called student T distribution. Okay? And you can also find this number from the T distribution table or by using R. Now notice that unlike the standard normal quantile, the T quantile will also need to input a number called the degrees of freedom, which is equal to the sample size minus 1. So I suppose you should have already seen this from the lecture notes or the lecture videos before. Now besides the confidence interval for the mean, we also need to construct confidence interval sometimes for the variance if it is unknown. Now the confidence interval is obtained by using this formula. You see, these two numbers will provide you the lower boundary and the upper boundary of the interval. And the numerator I say in these two numbers, which is equal to n minus 1 multiplied to the square of the sample variance. So essentially, it is just the same as the sum of the square deviation from the mean. Okay. For the denominator, it is obtained from a chi-square distribution table. So these two numbers will be the lower quartile, lower alpha over 2 quantile and upper quantiles. So this is chi-square n minus 1 distribution. We have these numbers. This is chi-square n minus 1, 1 minus alpha over 2. And this one represents chi-square n minus 1, alpha over 2. So that in between the area is 1 minus alpha. Because we are constructing a confidence interval with the confidence level 1 minus alpha. The coverage is 1 minus alpha. Now, this is the scenario when we have a sample from the distribution known to follow the normal. Now, there exists some other situation that we may join from a population, but we are not told that it is from normal. Then, if the sample size is large enough, we can also approximate by using normal. So an approximate confidence interval will be obtained by using exactly the same formula if the population variance is known. But if the population variance is unknown, we just simply replace it by S, the sample standard deviation. But this time, we don't need to change it into T. The reason is that when the sample size is large enough, T will be convergent to normal. So that we can just simply use the normal quantile. This is the situation in case when we are not told that the population is normal distribution. Now, there are also some problems that involve the population proportion or a probability. If we have a large sample drawn from the Bernoulli P, that means we have a sequence of success and fail. Success, maybe we encode it as 1, fail, we encode it as 0. We have a sequence of this 1 and 0. So that we have a sequence of Bernoulli terms. Each of them will have P probability to be success. And if we want to construct a confidence interval for P, we can do it using this formula. Now this x bar is the average of this 1 and 0. The average of this Bernoulli terms. In fact, this is just the sample proportion. Okay. The proportion in the sample. And then also plus minus the normal quantile. And this number is actually the standard error of the sample proportion. It is computed as square root x bar multiplied to 1 plus x bar divided by the sample size. So you can see in this kind of confidence interval, they take a very nice and regular format. Most of the time, we compute the confidence interval by using a number that estimates the unknown quantity, plus minus a number obtained from the table, multiplied to a number which is actually the standard error of this estimate. So in most of this kind of problem, estimating the mean or the proportion, we always have this regular format of the formula. Now, besides one sample problem, we also need to deal with the two sample comparisons. So if you have two independent samples drawn from two normal distributions, they may have their own population means, their own population variances. May or may not be the same. Then to compare the two population means, we will construct a confidence interval for the difference in this population means, mu x minus mu y. And there are different scenarios. If the variance are known, then the confidence interval will be constructed using the point estimate of this difference. This is what we want to estimate. We use the sample counterpart. Sample mean of x minus sample mean of y. Plus minus a number from the normal table and contact. Multiplied to this quantity is actually the standard error of this estimate. The square root of the variance of the x sample divided by m, where m is the sample size of the x sample. The variance, the population variance of the y population, divided by the sample size of the y sample. This is how we compute the confidence interval for the difference, if the variance are known. But most of the time, the population variance are known. So that we will estimate them using the sample counterpart. But there are two different scenarios also. If they are known, but I don't know why, somehow we believe that they are the same. We believe that these two population variants, we don't know the exact values, but we know that they are the same. If we assume that these population variants are equal, then the confidence interval will be constructed this way. Also, starting with the difference in the sample means, plus minus a table value from the t distribution. But this time, the degree of freedom will be the sum of the degree of freedom from the two samples, which is m plus n minus 2. And the standard error is computed making use of a sample, a pooled sample standard deviation, SP, which is pulling the two samples together using this formula. And then put into this, you can get the confidence interval. And you can refer to the lecture notes or video about the derivation of this. And finally, we have a more complicated formula in case when they are unknown and they are not equal. We cannot use the pooled sample standard deviation. So we just simply replace the sigma square and y sigma x square sigma y square by the sample counterpart. And for the t distribution here, the degree of freedom will be computed by using a very complicated formula. We call this the sector-based approximation. I don't know whether you are required to know about this to solve the problem in the test or the examination. I don't know, but they appear in the lecture notes. For completeness, probably. Now, for the proportion, we may also want to compare the proportion from two populations. So if you have two large independent samples from two populations with different proportion Px and Py, then the confidence interval will be obtained by the sample proportions from X sample and the Y sample. We take the difference of them, plus minus a normal contact, multiplied to the standard error of this difference, which is obtained by this at this, where m and n are the sample size of these two samples. So all this will be the formula, the basic formula to tackle this kind of problem of constructing confidence interval under different scenarios. So it is just a summary of what you've learned from the lecture so far about confidence interval. Okay? Just let me know if you have any question about them. Now actually in this worksheet, in the worksheet example sheet 9, we don't need to use all of them. Okay? We just need to use some of them. So we will start with the later questions, and then we go back if we have time. So you may try to spend a little time to work on question number 6. Try to find out the correct and appropriate formula to answer this question. So I can see some of you have picked the correct formula to start with. So usually this kind of problem you need to identify which scenario it falls into. So first of all, we are told that the systolic blood pressure is following the normal distribution. So we see the keyword, normally distributed. So you are told that it follows the normal distribution. And another keyword is unknown. The population variance is unknown. So from this difference formula, you see that it falls into this category. We have a single sample from the normal distribution. You are told that it is normally distributed. And the variance is unknown. And you are constructing confidence interval for the mean. And therefore, this is the formula that we need to use to calculate the confidence interval. So a 98% confidence interval for the mean, you use this formula. And in this formula, the sample mean is given. The sample standard deviation is also given because we have the sample variance here. So the sample size n is equal to 30. So what we need to do is to find out this compound. So now we have 1 minus alpha equal to 98% or 0.98. So alpha is equal to 0.02. And 1 minus alpha over 2 is equal to 0.99. So we need to find out T n minus 1 mass alpha over 2 as T29 because n is 30. 1 mass alpha over 2 is 0.99. So we need to find the 0.99 quantile of the T distribution with the degree of freedom 29. You can find it from the T distribution table, or you can use R. We call that in the lab. You've learned how to find the quantile of a distribution. It is done by starting with a letter Q. To find the quantile, the function starts with Q. The next is the keyword for the distribution. Here we want to find the quantile for the T distribution. So the function we need is Qt. And you need to input the probability for calculating the quantile. So P is 0.99 because we want to find the 0.99 quantile. And you also need to input the degrees of freedom, which is 29. So you will find that it is equal to 2.462. You may also find the same number from the T distribution table. So we have every ingredient to substitute into this formula. The sample mean plus minus the T quantile multiplied to the standard deviation. And don't forget to take the square root because you are given the sample variance. The standard deviation will be the square root of it, divided by the square root of the sample size. Then the rest will be routine calculations. Expressed as an interval, it is from 120 to 134. Okay. So the calculation will be quite routine. The crucial part is to identify the correct formula to be used and also to find the correct number for this quantity. Okay. Is there any question? So maybe we consider question number 5. Now question number 5 is a little bit different because we are not asked to find the confidence interval, but this question is related to confidence interval. Actually, it is the sample size determination. So maybe I just briefly explain how we can tackle this kind of problem. Now in this question, we are asked not to find the confidence interval. We are asked to find the number of measurements we need to take such that the confidence interval is not too wide, with the width not exceeding 0.02. So it is a requirement we put to the confidence interval. We want the confidence interval to have the width no greater than 0.02, from which we determine the sample size. Now, because it involves the confidence interval, first of all, we need to identify which confidence interval formula we need to use. And we are told that it follows the normal distribution. And we are also given the population standard deviation. So the population variance is known. We have a normal population, so that the confidence interval for the population mean will be obtained by using this formula. Now, based on this formula, we can write down an expression representing the width of the confidence interval. Because the confidence interval is actually extending from the mean to the right-hand side by this quantity and also to the left-hand side by this quantity. So the width of the confidence interval will be equal to 2 times the margin of error. 2 multiplied to this quantity will be the width of the confidence interval. And since we are already given the value of the sigma, which is 0.05, so we can write this as 0.1 divided by square root n. Okay? 2 multiplied sigma is equal to 0.1. So it depends on the value of alpha to determine the value of n, in such a way that we need L to be not exceeding 0.02. We don't want the confidence interval to be too wide. We want it to be narrow enough so that it is informative. So we want L to be less than or equal to 0.02. So we want this quantity to be less than or equal to 0.02. So this will become a problem of solving an inequality. So we find that the sample size we need, the number of measurements we need to take, will be at least 25 multiplied to this quantile square. This is done by solving this inequality based on our requirement. So it depends on which coverage we need. For example, for a 95% coverage, alpha is equal to 0.05 and the quantile is equal to z.975, and you will find that it is equal to 1.96 either from the standard normal distribution table or by using R. So we will need at least 9 different measurements, because we need the sample size greater than or equal to 96.02 of 0.04. And since the sample size must be an integer, so we need at least 97. So this is actually a typical way how we determine the sample size that we need in order to achieve a certain accuracy. And for part 2, you can just do the similar calculation by using different value of alpha. So I'm not going to repeat here. Okay? Any question? So because we don't have enough time, so maybe I will just directly work out how to tackle a particular problem in terms of the proportion. Now, so this is the typical problem in question number 3. A typical question that you are asked to construct a confidence interval for the proportion or a probability, P. So we have a random sample of households. We have the sample size 500. And we know that 80 of them are found to have 3 or more TV sets. But we are asked to find a confidence interval for the proportion. So from this keyword, you can see this question is asking for a confidence interval for the proportion. So it is a problem involving a proportion P. So for the formula you have learned about proportion, you can identify this formula. This one. Okay? For a large sample, the confidence interval for the proportion is obtained by the sample proportion plus minus the quantile and multiplied with this quantile. So a 90% confidence interval for the P is obtained as the sample proportion plus minus the normal quantile multiplied to this standard error of the proportion. Now we have the sample size n, which is given as 500. And alpha is determined according to this coverage. And what we need will be the sample proportion. But we know that we have a sample in which 80 of them were found to have 3 or more TV sets. So the sample proportion is obtained by the sample count divided by the sample size. So this is how we obtain this sample proportion. And alpha is equal to 0.1, so that Z1 minus alpha 2 is Z 0.95 equal to 1.645 from the standard normal distribution table or from R. So we put everything into the formula. The sample proportion plus minus the quantile multiplied to this standard error divided by the sample size 500. I don't have this number. I will directly write down the answer. So actually for the proportion problem, we've just learned about this formula. Okay? So we know that we should use this formula. But notice that this formula is used just in case when we have large sample. Usually when the sample size is greater than 30, we'll regard it as a large sample. That means if the sample size is small, like you have only 5 persons, a sample of only 5, you want to find the confidence interval for the proportion, you cannot use this formula. And what should we use? Something that you didn't learn at this moment. Okay? Maybe in some more advanced courses, you will learn how to tackle that kind of problem when the sample size is not large enough. Any question? So actually we are approaching the end of the semester. After the end of the semester, the schedule is quite tight this semester. Probably you'll have your final examination very soon, right? After the end of the semester. So is there any examination for this course? Do you know? Or test? Okay. But anyway, for the final assessment, it will be quite tight, the schedule. So you are recommended to do your revision as early as possible so that if you encounter any problem, you can seek help earlier. Okay? And notice that there will be no class next week for this session because next Monday is the bank holiday. Okay? So we'll meet next Monday. Okay? Okay. So is there any question? So see you next Monday.
This question asks for our household, the probability of our household. So why not the answer is this one? Because Because this is for one household, not all household.
Proportion, not probability.
Oh, okay.
So this is kind of just like the wording problem.
Oh.
So misunderstood the wording.
Okay. And I want to know, in exam, do I need to explain how this formula come from, like this one, or I
For
can
this standard formula, you can just directly use it unless you're asked to divide it.
Okay. Thank you.
Welcome.
office hour
I have different times table every week because I have a lot of classes. So I don't have a determined definite time slot for the office hour, but you can make an appointment in advance. So for example, if you want to know which time slot I will be available this week, you send me an email, I will tell you at what time I will be available. So you can make that.
Can I have your name so that I can search you?
Okay. Can I write here?
Yeah. Thank you. And like also here, the large sample number is considered as large because the teachers, the professor says 25 and you said 30, so which one exactly?
There's no exactly a common consensus because in most of the textbooks you use 30. But for this course, if the teacher told you that if it is larger than 25 is large, then you just stick to that 25.
Got it. And also, you know the notes that you explained it to us, those formula. I don't like, because it say when the m turns large, so the formula changed, right? But I can't find it.